Welcome to the Visual Components hosted webinar, How Can Manufacturing Simulation Help Your Team to Accelerate Sales? I'm Charlie Aldave, the head of marketing, coming at you guys from our headquarters in Espoo, Finland, which is just outside of Helsinki for the people who aren't really familiar with this area, like I wasn't when I first started with this company. I'm joined by some of our team out of our office in Lake Orion, Michigan, which they tell me I should say is part of the greater Detroit area, because not everyone's familiar with Lake Orion. So we have Graham, Scott, and Asiri who are going to be participating in the webinar with us. So we're excited to share with you how manufacturing simulation can be used to make your project and proposal teams more effective. And we'll spend the next hour showing you how some of our system integrator customers use visual components to get an edge in the RFQ response process. A couple of quick things to cover before we get into the presentations. First, since we only have an hour and plan to be using the full amount for this webinar, we probably won't be able to take any questions while we're live. If we do have some time at the end, we'll open up the forum for some questions, but we'll be following up with all of you after the webinar and can answer any questions that you might have. You can also use the chat feature on GoToWebinar to post questions, and we'll address these in our follow-ups with you. And second, if you would like to enjoy this presentation again after we're done, the webinar is being recorded and will be made available on our Visual Components Academy website, which you can find at academy.visualcomponents.com. So before we launch into the main topic for today, I wanted to give you a quick introduction to Visual Components. We were founded in 1999 in Helsinki, Finland. Scott Walter, one of the co-founders, is on the call, and we'll be talking with you more once we get to the demo. Since we started, we've grown to cover most of the world. We have offices in Espoo, Lake Orion, and Munich. We have more than 20 partners and resellers worldwide that we work with, and we have more than 4,000 active licenses in use. Our customers include some of the biggest brands in manufacturing and system integration. Our solutions are primarily geared towards two types of teams: project proposal and sales teams, which is what we'll be talking about today, and manufacturing, design, and planning teams. We also have a platform or a white label solution for companies that want to build or brand their own simulation solutions. And we've partnered with several companies to do this. Last summer, we launched our new product family, Visual Components 4.0. This is the biggest update we've made to our product since the company started. And we're pretty excited to be demonstrating for you today how it can be used to help improve the performance of your proposal teams. It's built on a new platform, it's much more capable, and includes several useful improvements and new features. So the topic for today's webinar is how can manufacturing simulation help system integrators to accelerate sales? We work with a lot of system integrators and machine builders, and we've been working with these types of companies since our company started. In fact, our first product was a layout configurator for a Finnish machine builder. The reason, it helped them to sell their vision. It was an incredibly powerful tool for a growing Finnish company that wanted to expand into fast-growing markets in Asia and North America. Being able to present their vision and capabilities with a 3D animated simulation helped them to bridge communication barriers and build credibility. Fast forward 18 years later, and a lot has changed in terms of both simulation technology and the competitive landscape for system integrators. The power and capabilities of commercial manufacturing simulation technology has increased significantly, as has the benefits it provides to system integrators. So just a quick overview on what we're going to be talking about today. I'm going to give you, as brief as I can, a presentation on manufacturing simulation and how it can help you to accelerate sales. I'll talk with you a little bit about how you can get started with manufacturing simulation software, specifically our software, and then we're going to have a demo about a quick turn RFQ response. So how does manufacturing simulation help system integrators to accelerate sales? Well, in short, it makes project proposal teams more productive and more competitive in the RFQ response process. It helps to improve the quality of their project proposals while reducing the time it takes to create them. Over the next 15 minutes or so, we'll tell you about some of the ways that manufacturing simulation can help you become more productive in responding to RFQs and winning projects. Afterwards, we'll provide a demo of how a typical system integrator might use our software to respond to an RFQ. So one of the major pains we've heard that system integrators experience in the RFQ response process is the amount of time it takes to create and update proposals. And this can be due to a number of factors: slow internal processes and protocols, inefficient workflows, not having the right tools for the job, and of course, not having enough resources. And we hear that one a lot. So, how can manufacturing simulation software help you to respond to RFPs and RFQs faster? Well, it saves you time on three key activities: creating layouts, performing analysis, and creating content. First, I think it's important to draw a distinction between creating and designing layouts. Creating layouts involves producing a layout, usually a 2D drawing of a production, and you can do this with many CAD packages. Designing a layout is designing a production line. It's an iterative and collaborative process that requires design and analysis, considering constraints and requirements, and evaluating trade-offs. Depending on the project, it can involve many tools and require input from many individuals and stakeholders. Creating and modifying layouts should be an easy task. It is, at least with our software. And as we'll show you in the demo, it's as simple as searching your component library for the equipment or the components that you need and dragging them into the 3D world with your mouse. Parametric components make it easy to resize equipment to fit your production design, and compatible components snap together to form connections, so you can quickly create stations, lines, and even whole factories. Creating and modifying layouts with pre-made components is very easy, often taking only minutes, so you can focus your time on the hard work of design and optimization, not creating the layouts. This brings us to our next point. Manufacturing simulation can help speed up the time to perform analysis. Tasks such as conducting reachability analysis or evaluating the performance of production lines have become more challenging as production lines have become more complex. This, of course, leads to more room for errors, which we all want to avoid, and we'll talk about more in a bit. But the takeaway is that manufacturing simulation is built for this type of work and provides fast and accurate results for a range of analyses you may need to perform on your production design. So after you've done all the work of designing your layout, you need to put your work into a format that you can share with your prospects. Again, depending on the tools you use and the type of content you need to create, this can be another time-consuming task. Our software can export a variety of products with marketing-grade quality. We call them project-ready deliverables. This includes 2D drawings, high-resolution screenshots, and 4K HD videos, and the ability to export these into a range of formats, including 3D PDFs, which you can easily share with your team or with prospects. And we'll go into this in more detail when we get to the demo. And this graphic here is just an example of some of the export products that you can create from our software. The large image is a screenshot of our product, and those smaller images beginning from the top is a 3D PDF. The middle image is an example of a video you can create and share on YouTube or whatever type of video hosting source you want to use. And then the bottom image is a high-resolution screenshot. So reducing your response time to RFQs is great for making your proposal teams more productive, but what is speed without accuracy and quality? I'm going to guess that most of you don't like making careless or avoidable mistakes in your work, especially work that you submit to clients or prospects. It makes you look bad when you have errors in your assumptions, analysis, and recommendations. And when they see these mistakes and errors in your proposals, it damages credibility and trust. Manufacturing simulation technology like ours can help you get speed without sacrificing quality. It's purpose-built for designing manufacturing and production solutions and performing a lot of the heavy simulation and analysis. This helps you avoid those careless mistakes and also helps you avoid two very bad, very expensive mistakes. The mistakes that cost you money and the mistakes that cost your customers money. The mistakes that cost you money are the projects where you over-engineer your solution, like adding additional or unnecessary equipment, forcing you to increase the price of your bid, and potentially losing out to a competitor that comes in with a lower bid, or forcing you to sacrifice margin so your bid can be more competitive. The mistakes that cost your customers money are delays and cost overages for projects you've won. And the mistakes that cost your customer can also cost you, reputationally and maybe even financially. Manufacturing simulation helps you to design the right solution for your project and visualize where there might be issues and opportunities, so you can avoid nasty surprises mid-project and save money for you and your customer. And this is an example of conducting a reachability and collision analysis with one of our products. This is with Essentials, I believe. Okay, so communicating your work to prospects can sometimes be challenging. There could be barriers that make it difficult to explain aspects of your design to people who lack your knowledge, or you could have a complex case with lots of information from different sources that you need to spend a lot of time distilling into a product that you can present to your prospect. There's also the problem of internal communication. We often hear the challenges faced by teams in communicating their work with each other, which can lead to delays and mistakes in putting together proposals. So how can manufacturing simulation help? Well, it helps with the data visualization problem. There's a lot of data, assumptions, and analysis that goes into designing a production. It can be difficult to present this information in a coherent format, especially if it was generated using different tools. Manufacturing simulation software like ours provides a platform for manufacturing professionals to illustrate and visualize the many layers of data used to design production lines. It also helps to ensure significant information isn't overlooked, such as assumptions and data that might be buried in models and footnotes. We're visual creatures, and showing is often more effective than telling. The ability to collaboratively visualize and explore a manufacturing process with others makes it significantly easier to convey complex information and helps you make a much more compelling case to your prospect. All right, here's an example of a statistical analysis of a production line with Visual Components Essentials. So I think we're going to kind of show you a bit of the kind of the abilities of our software to perform these statistical analysis in the demonstration. But as you can see here, it has like a very nice, easy to understand view of what you're looking at, and it's also very, even in this form, pretty presentable or shareable with prospects or customers. So one of the leading reasons we've seen system integrators adopt manufacturing simulation for sales is to differentiate their proposals or offerings and get ahead of the competition. Being able to create marketing-grade content with engineering-grade accuracy can help you differentiate your offering and give you an advantage over the competition. Manufacturing simulation helps you to create an easy-to-grasp visual representation of the production line you're designing. You can export an animated video up to 4K HD quality with our software, or a 3D PDF that illustrates your proposed solution with an embedded simulation video and bill of materials. You can even present your solution in the context of your prospect's facility by importing a point cloud model. This makes it easier for them to see what they are buying and oftentimes provides that crucial context and evidence that can't be gleaned from spreadsheets, drawings, and explanation. And we'll get into that more in a second. We have a lot of stories of how system integrators use manufacturing simulation to get an advantage in the proposal process and win projects, and how it helped them to differentiate their offerings from competitors. The biggest benefit with manufacturing simulation is that it helps you to sell the vision, especially for large, unique, or more complex projects. Being able to present your prospect with a high quality rendering or video, which you can easily export from our software, provides them with that crucial visual proof. And here's an example of a high-resolution screenshot that you can take from our product. Okay, which takes us here. One of the most important benefits of manufacturing simulation for sales is the ability to show the evidence, the proof, that you can deliver on your proposal. Our software helps you to do this in a couple of ways. First, it helps you to prove that you can deliver on what you say you can, that your solution is technically and financially feasible, meets your prospect's requirements, and that you're capable of building and delivering it against the schedule you proposed. It also helps you demonstrate that your solution can deliver the performance that you're quoting. Walking your prospect through a simulation, you can show how your solution will be able to meet production requirements and highlight bottlenecks and other potential issues in the production or individual stations. We found manufacturing simulation is especially helpful for system integrators that are proposing complex solutions or solutions they lack experience with implementing. While price is important when bidding on many types of projects, experience and track record also rank as pretty important factors. And even though there's no direct substitute for experience, presenting a realistic, visual, and interactive design helps you to make a strong case that you're capable of delivering. Another way manufacturing simulation helps you make your case faster is that it lets you show your prospect what's possible. This is especially helpful for explaining systems, techniques, and processes in the solutions you've designed. And as I already mentioned, it's also great for illustrating complex processes in more detail. Manufacturing simulation is also a useful tool for helping your clients and prospects to understand aspects of your solution that they're not familiar with. You can drill down to specific machines or stations to show what's happening, or walk them through the trade-offs between different layout configurations and show why the design you want to go with is the best. It's even possible to collaborate with them in designing layouts and processes. We work with some system integrators that allow their sales team to do this with clients during sales meetings, and it can be a pretty effective strategy depending on the projects they're bidding on. The last thing I want to touch on here is that manufacturing simulation software can help you to engender confidence and trust from your prospects and clients by being able to present them with a realistic, visual, and interactive model of your proposal. So, what about implementation? Well, the implementation process for our software is pretty quick and simple. First, it's easy to deploy. We offer standalone and network licenses. Visual Components 4.0 works on the same computers and laptops that most professionals use, with no special or unique hardware or software requirements. It's also easy to learn. It takes only a few hours of training to learn how to use Visual Components Essentials, which allows you to do everything that we're about to demonstrate. And I also want to emphasize that you don't have to be an engineer to learn or use this product. It's used by technical and non-technical professionals. We also have a lot of training and tutorial resources available online. And last, it's easy to get started with Visual Components. We've designed a lot of simple workflows in the product to help perform the most common tasks. We also have a large library of pre-built components that are freely available to all users. Okay, so I think at this point, you guys have heard enough of me talking. So now we're going to show you an example of how a system integrator might use manufacturing simulation to respond to an RFQ. In this demo, our prospect is a small to medium-sized manufacturer that's looking to make some changes to an existing palletizing process. At the end of their manufacturing lines, the actual palletizing is performed with a robot, but the palletizing line still uses human resources, and the prospect is interested in reducing the headcount on this line. While the palletizing line is functional and meets the prospect's current requirements, the prospect is concerned about their ability to respond quickly to possible changes needed in the end-of-line process. They somehow want this line to be more flexible and help them become more responsive. They also want it to scale and evolve as their needs change. The prospect approaches the integrator without many specific ideas on how to do all this, but a pretty clear desire to update and further automate the process. And of course, they have a strong sense of urgency. The prospect has never used manufacturing simulation and has always relied on 2D CAD, Excel sheets, and flow charts to implement the different manufacturing processes. They're unsure of what changes will have the biggest impact on production and don't want to waste time after installation fine-tuning the process. So this is a pretty common scenario we hear about from the system integrators we've worked with. Lots of ambiguity and oftentimes conflicting needs and requirements for the problems they're asked to help solve. So at this point, I'll turn it over to the team in Michigan to present the demo.
All right, and this is Graham from the Detroit office. Is everyone able to hear? Or Charlie, we have good sound?
Yep, you guys are good.
Okay. Well, thanks for your attention, guys. Like Charlie said, that is a fairly common manufacturing scenario. Customers or prospects will approach you with ideas, some good, maybe some not so good, and it's up to your sales and layout and planning teams to come together with a singular vision to meet those customer needs. Because this customer has never dealt with simulation, all their information is in CAD and Excel sheets, and we need to take and make use of that information. With our software, we have the ability to import all different formats of CAD. In this case, we were given the 2D drawing of the layout. So what we're going to do is we're going to go ahead and grab and bring that in real quick as a customer layout and drop that into the simulation so we can start to see the process. While the geometry is there and we can see the layout, there isn't a whole lot of explanation included. Sure, we can get an idea of a case rate. Sure, we can get an idea of the product flow and which direction things are going, But in order to make the best recommendations to this customer, we have to first better understand their process. And we can do that very quickly by building their process and analyzing it. Charlie talked about our library of pre-existing components, which is what we're going to use to build this simulation. We search for components and can simply start dragging and dropping those components into the world in order to use them. I'm going to go through our ECAT and drag in some of the components I know we're going to need to use in this simulation. Let me go ahead and grab a couple more of these, and we can start to talk about some of these components individually. We can't have every piece of equipment out there in the manufacturing world. It's not realistic, but in order to combat that, we make components that can be parametric. If we take a look at this conveyor, for example, we can take a look at its properties. On the left-hand side of the screen are all the things about that conveyor we can change to meet our unique needs and requirements. This conveyor is currently 5 feet long, but in the case that's not long enough, we could change it to any one of these preset values, and if we choose a 10-foot conveyor, the conveyor will rebuild itself to the correct configuration that's now usable to us. Many of the components we have in our library are designed to be parametric like this, so they can be quickly adjusted to meet individual requirements and needs. The software is also unique in the fact that we can bring in individual components, or we can bring in components as groups. In the course of building multiple manufacturing processes, no doubt you use the same styles or types of lines more than once. What we can do with our software is group some of those components together and we can reuse them. For example, if I want to implement a feed line rather than bringing in each component individually, I can go ahead and bring in a group of components that I can use. We then take that group and we spin it around. And what we can do is we can put it in the approximate location that we need for this process. Our components are designed with simple interfaces. And as we take and use these components in our 3D environment, we can drag them next to each other and they will snap together if their interfaces are compatible. We can change different things about these products as we bring them in to meet the needs. I'm going to go ahead and bring in a conveyor line that we're going to use in this scenario. I can take and drag as a group this conveyor line. Looks like I got the other one as well. But we can take them, and the great thing about this is as we move things around and they're grouped, we can quickly make changes based on new needs, new locations, and new floor plans. I'm going to take and snap my conveyor drop-off point to that conveyor, or my pallet drop-off point. And I only need three more things to put in the world. I'm going to need a pathway for my forklift. We want to make sure it doesn't run into any other equipment. So we'll put him right here, dictating where he can and can't travel. We're going to need our robot. So let's go ahead and look in our catalog and drag him in. And let's go down the list. And here we go. Robot on the riser already. And we'll put him where he needs to be. We're also going to need a human to load that first part of our cell. So let's go ahead and grab our favorite model, Anna, and put her over here for that process. We only need one more thing to make this entire layout work, and that's our palletizer component. This is going to be the brains of our entire operation. Too often, when we talk about simulating complex processes this early on in a sales cycle, it's not efficient. There's too many signals, there's too many connections, there's too many things to teach. So people say, you know what, simulation isn't for us. We dispel that myth by making smart components that do a lot of the hard work for us. I'm going to center this guy on the path real quick. I'm going to change the pattern to the dictated pattern of just a 3x3 pattern. And our box size is actually 15 by 11.5 by 8. And we can see that with those configurations, that pattern will fit on my palette. Let's just say we're going to make it 3 layers for now, and we should be all set. In order to make this work, we do have to make a couple interface connections. That smart component gives us a list of things we can connect. We're going to connect our robot, which turns green and shows that we've made our connection. We're going to connect our product source, and we're also going to connect our product feeder. Once we've made these connections, all we have to do is hit play, and we can start to better understand the customer's process. We see the human loading the pallets. We see the pallets traveling down the conveyor line. And we see the robot picking up the product to palletize for us. Looks like our pallet's in the wrong direction, so we can very quickly take him and rotate him just a little bit so we make sure that he fits the right way. Once we've done this, like I said, we can start to analyze the different things going on in the customer's layout and then start to make recommendations based on that. And to do that for us, we're going to have Scott step in as playing the role of our process engineer to understand what's going on so we can then collaborate with our layout planning part of the proposal team, and they can generate something for the customer that meets their needs. So welcome, Scott.
Thank you, Graham. Okay, what I want to do is take a look a little bit at the process, and the best way to start out is to begin to run the simulation. It's going a little bit fast right now, so we can slow it down so we get a better idea of what the robot's actually doing. I'm going to put it in more of a real-time mode so we can see how it's behaving. It's picking the boxes up, you see, in group of 3 at a time. And then we'll be coming in and then dropping them off once the pallet arrives. It's rather amazing how slow real-time is when you're used to running things much higher rate. Okay, it's coming around, doing the grabs, picking them up, dropping them in. Okay, that's the 3x3 pattern that we were talking about. And you can see the robot seems to be able to keep up quite well with whatever the cases per minute are that's being produced by this line. So we're able to see this a bit qualitatively, that the robot has a lot of bit of extra time. What we'd like to do is maybe analyze it and get an idea of what kind of throughput can we actually expect with this robot with this particular pattern. So in order to do that, I need to pick my pallet base, which will become the active component, and look at the component properties, which we can see over here. And I'm going to now pin this menu right now so it won't keep on hiding on us. So we can have a better idea of what some of the properties are. Now, Graham has already gone through and has made sure that we have the right size dimensions for our part, which is our product, which is 15 by 1.5 or 11.5 by 8. We're building 3 layers. I think actually the customer says they want to go up to 6 layers, so we'll go ahead and build more layers if we want in there. And the pattern seems to fit fine. But right now, we're producing it at a rate of about 14 per minute. So we have the number of cases that are coming out. I want to bump that up to, let's say, about 20 and get an idea of what's going on. So we'll go ahead and try the higher rate. And then let's go ahead. And then down the bottom of this component, we can begin to get an idea of what the throughput starts to look like. I'll increase the speed a little bit more so we start to gather more and more statistics about this. And we're able to see that, okay, it's keeping up, and these are actually bursts that we're able to see, burst rates of 14 cases per minute. So it's having no problem sort of being able to keep up with it overall. We get an idea of what our pallet build times are, etc. But now the customer has told us there's going to be a slight change, a slight twist in that they want to run a special on this product where they're going to increase the size of the product to run some sort of special. So it's one of these sort of 20% extra for free. And in order to do that, they're going to have a bigger box for the product. And they've informed us that rather than going with the 15, they're going to go with 17-inch. So we'll go ahead and put in the 17-inch. And as soon as we find out we have a 17-inch length box, we can see it overextends our pallet. So that means we cannot use a 3x3 pattern. And we'll let them know that you're going to probably have to go to something like a 4x2 pattern like this, which will have the advantage that we can probably pick up 4 boxes at a time and drop it on there. I'm feeling you can actually palletize faster, but we've lost a box. And losing a box, especially if we're having 6 layers, that's 6 boxes we're losing per pallet. That means if you want to be able to ship the same quantity, you're going to be shipping more trucks. So to get around that, they really want to know, well, is there some other pattern that we can use that can still get those in there? And that's not as straightforward as a 3x3 pattern as we've seen. So if we go back to the 3x3, you can see that's going to just fit over a little bit, but we can see the pallet has a little bit of extra. Is there any way that we can accommodate that? Well, some clever people usually figure out that if you do a nested pattern like this, you can actually get those boxes to fit handily on that pallet, and you now have enough pallets on there. And you might think, good, we're out of the woods, we can go ahead and use this, but you've got to think about it for a second. What steps does the robot have to do to actually build a pattern like this? And so if we run the simulation, we'll get an idea of what that's about. I'm running it a bit too fast here. Let me slow this down. I had it a little bit too fast there. Let's go ahead and get it back up. Oh, and I think I did something to my palette right here. Let me just, I think I accidentally bumped it off of here so it wasn't on, it wasn't positioned correctly. Okay, let's go ahead and run that again. Okay, so we can see it's building it up. And as it's building it up, we can see, if I slow this down a little bit again for us, going a bit fast on the top speed, that is, it's not as easy as just dropping off the whole line of boxes. In some cases, we actually have to do 3 additional moves to drop the box off. So in the middle row, we have to do 3 drops, and in this one here, fortunately, we can get by with just 2. Now the result of that, and we can clearly see this already, is that we're starting to get backup over here on our line, which means we cannot get the same throughput as we did before. So our cases per minute rates are going to drop down. We're not able to keep up with the cases per minute, which was 20 before. And so we can see there's a problem. Now again, I said this is kind of a quantitative approach looking at this. If we want, we can also take a look at the real statistics on the robot to get an idea of the feeling of what the throughput is. You go ahead and start that again.
Or click it for the pie charts.
Yep.
Doesn't matter.
Okay, and so we can see that if we're going to have some sort of compromise right now, if we decide to go ahead and use a more complicated pattern, which is going to limit the throughput, and that can be important feedback to the customer that if you change the way that you do the palletizing, that something may happen to your overall throughput. And these are sort of the quantitative analysis that we like to do when looking at the robot or looking at the pallet information to get an idea of what kind of throughputs we can expect.
Okay.
Thanks for the analysis, Scott. And this kind of highlights the importance of even understanding the existing customer layout and their process. There may be ways to improve throughput or ways to analyze what's being done simply based on running their layout in 3D and changing different things about it and seeing the results. Now that we've done this analysis, now that we've talked to our process planning people, and we've collaborated with our layout people, all using the same software, the layout planning people get back to us with a new floor plan. They say, you know what? We've improved the process, we've added some steps, and we think that this is the new way you want to go. So what we're going to do is we're going to import a new layout, and we'll take that DXF and match it up to what we have before. So it's pretty close. And what we're going to do is we're going to see that this line is vastly different. We've changed things about it. We don't need it anymore. So what we're going to do is we're just going to start getting rid of the unnecessary parts of our simulation. We talked about reducing a head count, so we don't necessarily need that Anna anymore. We're going to, once again, get rid of the conveyors that are there. And lastly, actually the path 2. And then lastly, the outfeed conveyor, because that's going to change a little bit as well. We showed you earlier how each conveyor was parametric. So if we needed to, we could rebuild each section and put it together so it would fit the necessary lengths for this process. We also talked about it being modular, so if we needed to, we could bring in large groups of components at once. And that's what we're going to do here. In the revised layout, what we can do is bring in a new conveyor line, and we can take it and match it up to the DXF that we were given by engineering. Take and grab that whole group and move it over. It makes for a very quick, very easy representation of what we could potentially add and put into the cell. Because we have different pickup and drop-off points with the forklift operator doing both processes, we're also going to need a new path. And we can take that pathway, drag it in, and drop it right here so the forklift can reach all of the areas it needs to. Okay, I'll actually scooch it over just a little bit. And there we go. We have our pallet here. Well, we've already brought that in. We've seen that what the changes need to be if we're going to make a 3x3 pattern. So that's what's in there. But on top of that, what we've decided to do is we've decided to add a sheet feeder. So we're going to go ahead and grab the sheet feeder and put that in there. We just look for it in our library of components, and we'll add him over here. Because the forklift is now picking up the stack of pallets, we also need a pallet dispenser. So we're going to, once again, return to our library, and we're going to grab a pallet dispenser that we can now plug in to that line. We take a look at the pallet dispenser, and we see that it is not actually creating any pallets, it's just waiting for them from an outside source. We're also going to add a product wrapper on the end of this line. Okay, so let's add our wrapper. Once again, pre-designed to snap in to an existing line. Let me snap him in there. And there we go. We're now connected. So we have a representation of our new and improved automated line that can handle more complex palletizing scenarios. Just like before, all we're left with is making some connections. We take a look at our palletizing component and look at its interfaces. Just like before, we start making connections. If we choose to connect the sheet source and drag our virtual wire out, we see the sheet stack turn yellow and then green once a connection is made. We connect our robot the same way. The robot's now connected. We connect our source, which is where it picks it up from. And our very last thing is we're going to still connect that product feeder. Now that all of our connections are made, we can sit back and we can take a look at this scenario, hit play, hit play. There we go. And we can see it in action, including the changes we've made. We can start to analyze what happens. We can start to see the interoperability of the different parts. We now see that the forklift has quite a ways to travel between the two sides, but with the reduced human count, the resources, maybe it makes sense to leave it just like this. Once that, and I'll speed this up just for the sake of the early part of the simulation, once we see the forklift pick it up, the forklift will then drop off our product, the pallet, oops, and I'm not connected here, hold on. Let me reset this, sorry guys. Here we go. Snap him back in, and now we're all set to go. So, once again, as long as all the connections are made, we can start to analyze that process. And we see our forklift drive over, it's going to begin to pick up the pallet stack, drop it off, the dispenser will then dispense the pallets, and we can start to see our palletizing process. Notice this time the robot has not picked up product yet, because we've told it we want to do sheets in between each layer. We now see the robot doing that by picking up the sheets and then picking up the product and continuing on with the nested 3x3 pattern. We see it doing different layers. We can tell it to put layers in between, or sheets in between each layer if we want, and see what our results are going to be. Once it finishes, I believe I have 3 stacks, but once it finishes all 3 layers, it will then go down to our pallet wrapper, where it will be wrapped, and then it will be exported for our end of our line. And we can see the wrapper spinning around, it does its process, and we're all set. Now that we've got this and we're comfortable with it and we think we have a good solution for the customer, the next step is to share this with them. In our software, we have the ability to create 3D PDFs directly from the software. You may be familiar with the 3D PDF, where you can take an object in 3D, zoom, pan, tilt, rotate, and get a much better feel for that product. We've enhanced that and taken it to the next level, where we include motion and movement as well. Up at the top of my screen, in the simulation controls right in the middle, we have a button that says Export to PDF. We can click on this at any point in the simulation and start recording our model. What this does is this allows, once again, the ability to share information with virtually anybody. Most computers out there nowadays have Adobe, and that's all you need to read this. We hit Start Recording. We take a good part of the scenario, and then we can send it to them and share the ideas. This is a 3D PDF of the line we just talked about. All of the elements, all of the things in there, and if we hit Reset and Play, we can see exactly what we saw in the software. We see the same process, we see everything that's going on. This is sped up slightly. I think we're running at about 5 times speed, but you can definitely see the process. The advantage to this is, once again, being able to show the customer every step in the process. If we take and click on some of these objects as well, in our bill of materials in the upper right-hand corner, you can see information about each one of the processes. For example, I click on the robot and it automatically tells us the name of it up top, then it's a 5-axis palletizing robot below. If I click on my sheet bin, it will take me to that sheet bin and let me know that the max sheet count is 60 and the average refill time is also 60 seconds. We can include any information we want about any component in the entire process, so the customer not only sees it, but basically gets a handheld walkthrough about every step and every process, including times if that's what we want. We can take this 3D PDF or AVIs, or, as Charlie showed us earlier, high-resolution screenshots directly out of the software in order to make our case and our presentation. Because we're able to not just show the motion and movement, but to include the statistical analysis about the number of cases that we can service an hour, what the impact different patterns will have, and what the impact different steps in our process will be, we can, with a much higher degree of confidence, approach that customer with a working solution. We send this information to that customer and sit back now and wait for the order. Well, that's what we would do in an ideal world, but we all know that a lot of times with these customers, we have a moving target. Things are always changing, things are happening, different requirements are out there, and we need to be able to respond quickly to those. The customer loves what we've done based on what we've shown them and wants to do even more. Instead of just palletizing their one larger size box, the customer now wants to palletize both the regular and the special version at the same time. They can't afford to not do one or the other. They need both. Unfortunately, they're limited by a budget and they're limited by space. We can't just create a second line and say, here you go. They want to know if we can take what we've done and just take it that next step and further enhance it. Use the same robot, use the same line, keep it fairly linear, and let's see what we can come up with. It's very easy for us to make those changes if we've got a clear target, or even a moving target. What we do is we take the new requirements and we're going to sit back down with Scott, our process engineer, and we're going to talk about some of the changes we can make. You already saw how we can very quickly make changes, drag things out. Because our components are parametric, we can make the changes that we would need. We've actually created a third layout that meets the customer's new needs. And it'll pop up in just a second. And now that it's popped up and we can see multiple infeeds and multiple palletizing stations, all while keeping everything in line, Scott can now start to explain how we can start to analyze even this new process and with a very, very high degree of confidence, troubleshoot that process ahead of time based on the interoperability and ever-changing variables present in the simulation, and we can give them our best recommendation and feel good about the results and the fact that what we promise is what we can actually do. So let's go ahead and have Scott step in again, and we can see what some of those variables are.
Okay, thank you again, Graham. So if we look at this layout, and I'm going to go ahead and put it back in kind of a real-time mode and let it run while I describe some of what's going on. And so as we start out, what you see is we spliced in an additional feeder line over here behind the robot. So we're using just the same robot, but we have two different products that are coming in, and depending upon the size of the product, they're being routed into the different in-feed lines here. And right now, the robot's not able to do anything because it's waiting for the pallet stack to arrive. So the fork truck driver has to get over and go ahead and get the pallet stack in there. And this is kind of will highlight maybe one of the flaws in this particular design, in that we're going to start to see a little bit of backup. Now, just to give you an idea of what's going on here, let's pause for a second. If we look at this pallet over here, this is actually the one which is palletizing what we call the extra product. So, but it's only being produced at a rate of 5 per minute, whereas if we look at the other pallet, it has a different rate. So it's coming in at about 8 per minute. So the overall, we're having 13 cases per minute coming on down there, but they're balanced a little bit different. So as a result of that, we're going to start to see potentially a backup on one of these lines if the robot's not able to start removing the product from the in-feed line. And so we see right now what's happening is we're getting a little bit of a backup, and now we cannot get the extra products to make it down to the other line until we start to clear out this little traffic jam. So the first pallet's going to come in, and of course it's going to get sent to the first station here, so we've got a little bit of delay waiting for the next pallet to come in. The sheet feeder is going to come in, the robot will come over and start to drop the sheets on there, and now it can start the process of the palletizing. As you can see, it's waiting for the product over here, so there's a little bit of a lag on that. We can get the next pallet coming in, and now we're going to start clearing this blockage and start moving around. So maybe there's something that would be a bit more desirable, is that since this is the high volume product, maybe it makes more sense to have it come over here rather than there. We can take advantage of this longer in-feed line to act as a buffer for us. Plus, we're able to get that pallet in there much quicker rather than waiting for the next one to come through. And that's pretty easy to do. So we'll just come back here and just say on this line here, rather than running the extra, just run the normal. And so just by, we can store all these properties underneath any sort of name that we want. So it's very easy for the customer to go back and reference that. And the same here is that we'll come back and then just say, oh, this one is going to be running now the extra. So now we're putting it onto different lines. We'll see definitely a different throughput. I'm going to speed things up a little bit to get the pallet feeder to start to bring the pallets in first. We get a little bit of backup here, but it's going to ease out a lot quicker because of that. So now once we start to get the 5 per minute line going, it starts to let things come through, and then eventually we're going to see that the lines clear out a little bit better. We're taking more advantage of the buffer over here. Now, another thing that was kind of brought up is that the customer is not quite sure about the shrink wrapper that we put on here, and is there a way of having a version that's a little bit less. Now, what we did is we brought it in with all of its capabilities, and in this case, they may be wanting to look at the component properties, and in this case, as you can see, the maximum load height here is 110 inches, which is a bit of overkill for what this customer needs. So just by asking them what's the largest pallet stacks usually make, they might say, well, it's a really 60 inches is the maximum they ever go to. So we'll go ahead and pick that, and that will now resize this the shrink wrapper to be a little bit smaller, so that will be a little bit more affordable. But another thing kind of comes to their attention is that, well, we don't need to have quite such a large film height on here. What options are there? Well, there's a 20-inch, so we can go ahead and change it down to a 20-inch. And there's maybe some other things we want to do while wrapping this. Is that, how much overlap are we going to have between layers as we go up, as we start wrapping? Before it was already at 14, which is about half of the actual film height. So if we want to maintain that, then we probably might want to go with just a 10-inch overlap. And then we can specify how many wraps, the top and the bottom. And this is going to have an impact on the overall throughput rate, but we can see whether that's going to have a problem with our balance. Is it going to slow things down too much, or is it able to still keep up? And as we run the simulation, we will see that, yes, it does keep up. And these are some of the, by having things parameterized, you will see not only an effect on how the products look or how the equipment looks, but you will also see an effect on how it runs through the simulation. Is it able to run faster or slower? Are you going to get bottlenecks as a result? So I see we're coming to close to top of the hour. I've made, I think, all the observations I'd like to make on this particular simulation right now. I'll turn it over to Graham, who will then turn it over to Charlie for a summary and wrap up.
You've seen during our completely live demo how we can take existing customer 2D data, build a simulation to analyze what they have, and then very quickly respond to changing needs of the customer based on parametric components. I don't know about you guys, but I would feel a lot better responding to a customer knowing all of these different variables, knowing all of the different changes, knowing all of the different things we have to offer based on a statistical representation of that cell, showing them that we can do exactly what we promised. Rather than guessing, rather than flowcharts, rather than sheets, being able to show a customer different trade-offs between different configurations is a very useful tool as we explore all the possibilities of that individual process. From the Michigan team, I want to thank you guys for your attention. I want to thank WebEx for behaving during our completely live demo.
And DTE for not cutting power.
Yep, and for Power for remaining on during our windstorm. Thank you very much again, guys. If you have further questions, Charlie's going to be addressing how to get in contact with us. We'd be more than happy to walk you through any of the individual steps that we took during the simulation and how simulation could better apply to your processes and how you would present your solutions to your customers. So again, thank you for your time. And Charlie, it's over to you.
All right, thanks, Grant. Thanks, guys. I'm gonna just take control of the screen again. Okay. So yeah, I actually got an email from Scott while they were giving the demonstration saying that the power went out in the building that was right behind them, and in some of the neighboring buildings. So I was just kind of here frantically waiting for something to happen and for this demo to go sideways, because I guess this is kind of one of those things to always expect to happen when you're doing something live. But fortunately, everything worked out pretty well. So I hope you guys all enjoyed, or guys and gals all enjoyed that demonstration, and were able to see the impact that manufacturing simulation could have on your project proposal workflows. So to quickly summarize what we reviewed today, manufacturing simulation helps project proposal teams to accelerate sales in 5 ways. First, by helping you to respond faster to RFPs and RFQs. And you do this by building layouts faster, performing analysis, and creating high quality content. Second, by reducing mistakes. You get speed without sacrificing quality, you avoid making expensive mistakes, and it can save money for you and your customer. Third, manufacturing simulation improves communication. It can help you to overcome knowledge gaps with your prospects and customers. It improves internal communication. It helps everyone to visualize your data and ensures significant information isn't overlooked. It helps you to get ahead of the competition, so you can create marketing grade content with engineering grade accuracy. It helps you set your offering apart. It can improve your win rate, and it helps you to sell the vision. And finally, manufacturing simulation helps you to make your case faster by helping you prove that you can deliver on what you say you can, showing your prospects and customers what's possible, and by building credibility. So this pretty much concludes our webinar. I want to thank all of you for joining us, and hope you were able to take away some useful insights and tips. Again, you can find the full recorded video for this webinar at our Visual Components Academy website, academy.visualcomponents.com. We'll probably post it there in the next few days. So thanks again, everybody, and we'll be in touch with all of you. We'll follow up with everyone with an email here shortly. So if you have any questions that came up from what was discussed, or just anything that you want to discuss with us afterwards, we'll be able to connect with you guys on that. So anyway, thanks again, and that's it.